All right. You good to get going here, Dan?
Yes, sir. I'm ready. Hope everybody else is.
Sounds good. All right. Well, welcome everybody to our cast condensing webinar series, the first part in this webinar series. So thank you for joining us here today. As you're probably aware, right, there's a lot of drivers out there in the market in the world that are causing people to at least consider converting their boilers from a cast iron atmospheric boiler to a high efficiency condensing boiler. Right. And you probably also know that it's actually not a very easy process to do that. Right. It's not nearly as simple, unfortunately, just taking out the cast iron boiler and dropping in a high efficiency condensing. Right. There's a lot of other things that need to be considered as you think about this project, and even more as you go through that type of project and go through that journey. And so that's what this series is for, is to help you make a more informed decision in terms of what's right for your project and your application. And we're just trying to get our experience over to you and let you know, help you make the most informed decision you can. A couple of housekeeping items before we get started here. If you have any questions, we want you to ask them. But your method of doing that is not through your voice. It's just through the chat function here. As Dan goes through his material, I'll be watching those, and we'll try to reserve as much time as we can at the end to go through as many of those questions as we can at the end of the presentation. The other thing is that you should know that this webinar is being recorded so that we can share it with you after the presentation, and also share it with people like you who weren't able to make it to the call here today. All right, and one more thing here, Dan, I wanted to cover was who we are. Dan and I are a part of HSSC, which is the sales and marketing division for a number of different boiler brands, including those that you see on the screen in front of you right now. And some of those brands you might be really familiar with, others might actually be new to you. But the important takeaway here is that we've got a lot of experience with a lot of different types of boilers. Right, as you go through these are just some examples of some of the boilers that we make. But we have experience from atmospheric cast iron boilers all the way to high efficiency condensing, both stainless and copper tube, flexible tube boilers, big steel Scotch Marine and fire tube boilers, and even electric boilers. And so the point is that we have these kinds of conversations a lot with our customers, and we've just asked Dan here to start distilling that information down and trying to help you, again, make a more informed decision using what we've learned over the years. So with that, I'll introduce you to Dan Reddig. He is our product manager for all of our commercial and industrial boilers, all of those brands that you see here on the screen. Hi, Dan. Why don't you take it away?
Yeah. No, thank you, Charlie, and I appreciate everybody spending the next 45 minutes with us. A little bit about myself. As Charlie said, product manager for all the brands that you see in front of you on the screen now. Been with the organization about 6 months now, but been doing product management for boilers for about 13 years. And previous to that was an HVAC service technician out in the field for about 10 years. So, probably show my, I hate to say this, right? Shows my age a little bit, but now been in the industry about 20 years, a little over 20 years now, actually going on 25. So, again, good industry to be in, and just kind of want to talk to you guys a little bit about, what we have going on now. I think everybody knows there's a lot of things going on as we start to, we're starting to see more products transition to that high efficiency. So just to make sure that we're evaluating that properly, right? So why may we be evaluating, moving towards high efficiency, right? So the big topic now is, decarbonization around emissions, right? So maybe there's some local things going on in your area that you're looking at. How do I lower my emissions? So we're going to talk a little bit about what, as a boiler manufacturer, we're required to do per our certification, and then some other standards that majority of the high efficiency condensing manufacturers are looking at. We'll get into efficiency. What are we required to do as a standard test procedure, and then talk about that third-party certification that you guys can use to verify what we're saying is our efficiency. And then we'll get into footprint. I think that's lot of people, if they haven't started to look at high efficiency, they're really amazed at the kind of the footprint that they save when they do make that transition. Um, and then just want to talk a little bit about water temperature system design. You know, as majority of you probably know, right, water temperature is very critical with condensing products. The colder water we get back, you know, the more efficient we are going to be. So we want to make sure that we can maximize that efficiency. And then also there are some limitations to high efficiency stainless steel condensing products on the top temperature that we can deliver. So that's something that I've learned over the years. Not everybody's aware of that. They may specify or put in a condensing product thinking it's going to be able to do the job that their previous product did. And we're just not able to hit those temperatures. It doesn't matter if it's our product or somebody else's product. And then we'll just kind of do a recap. And again, even though this presentation is, you know, we're saying cast to condensing, it could really be any product that you have in your current mechanical room, or you know, if you're looking to do a retrofit, just things we need to think about as we move towards high efficiency. So we'll talk or start around the emissions. So we certify our products to the ANSI standard, the Z2113. And within that standard, the only emissions requirement that we have to do is to be under 400 ppm on the CO. So we will make sure that we hit that. We will document that, and that's what we will submit to our ANSI standard. But that is not what majority of everybody's doing. We're looking at other standards out there and trying to get beyond that, under, you know, more than that 400 ppm CO. So one of those that you've probably heard a lot about is South Coast Air Quality Management District. So that would just be a lot of people refer to that as the South Coast state, the district, the South Coast emissions requirement. And we see this referenced a lot throughout other states. We see this in some of the government specifications, local municipality specifications. Even if it's not in that Southern California area, they still reference this because this is a really probably the most well-known documented emission standard. So what that standard has been historically is any product under 2 million. So that's why you'll see a lot of products not rated at 2 million. It'll be like 1.999, right, million. And that gets us so we can actually do a third-party certification on the NOx. And that NOx has historically been under 20 ppm for those 2 million and below. Anything that's larger than 2 million has had to be field certified. So that means somebody has had to go on site and verify the NOx levels. Now, there is some other third-party verifications. The Bay Area, so San Francisco, they have a test standard, but it actually is, you know, 30 ppm. So you could actually go larger, get third-party verification from the Bay Area testing, but that would only document under 30 ppm. I say historically, you know, it's been 20 ppm. So recently, actually just last end of May, beginning of June, I don't know the exact date, that they've just passed a new NOx standard that's going to be implemented in 2026, and it's actually going to require zero NOx. So now that South Coast, you know, which has historically been as what we've used as a kind of a baseline, the majority of the manufacturers to go for NOx rating, that's going to change. So we'll probably, nobody's really made that determination what we'll use for third-party verification moving forward, but we'll actually have to look for some other third-party verification, because again, they're going to zero NOx in the attempt, you know, in that Southern California area. What they want to do is drive towards electrification, remove, you know, gas products from their markets. So we'll have to, again, look for another third party to verify our emissions. So regulations, this is probably, emissions is the toughest thing, is from the boiler manufacturer side and also even from a design engineer. There's so many different regulations, whether they're regional, local, it's really difficult if you are a design firm and you're designing a job, for California one day, Florida the next week, and then the following month maybe you're up in Massachusetts, right? It's changes now per area that you're working in, so you really need to be aware of where you're at and what those requirements are. One specific area, if you look in Boston, they've got what they're referring to as the BERDO, the Building Emissions Reduction and Disclosure Ordinance. This is requiring everybody to start providing their emissions data. So they've had to gather this over a certain amount of time, and they're actually having to start setting guidelines for how they're going to lower those emissions. And then if they don't hit that, there's penalties. So there's, they can be fined. Depending on how large their building is and how far they're off. So there is consequences to not hitting these targets. And a lot of this is not even getting grandfathered in. So if they start to look at, well, we're going to be held in 3 to 4 more years what we put in today. So they're really having to move towards more high efficient products today sooner than maybe they would have if these kind of regulations weren't put into play. So just need to be aware this is going on all over the country. So you need to be up to speed on your area or where you're designing or you're putting the boilers so you can make sure you're helping your customers make the right decision. The next one I want to reference is really probably one of the more restrictive requirements. So it's 5 counties in Southwest Washington. And what it's doing is it's got a 20 to 50 ppm for the CO, which is very difficult from a combustion process to get to. And I just say this because as the whole, emissions reduction movement continues to grow, we're going to see a lot more areas, whether it's counties, states, they're going to start looking around, seeing what everybody else is doing. So all of this stuff that we're seeing out there is going to start spreading. Everybody's going to kind of tweak and pull pieces from the other regulations. So again, just trying to let everybody be aware that there's a lot going on out there, and we really need to be consistently looking at where we're designing for what those emission standards are, and that's going to help drive to make sure we're making the right decision for our customers. So we're going to move from emissions into efficiency. So just like the BERDO, the regulation that they're setting up in Boston, and there's similar, like I said, throughout the country. There's also building efficiency performance standards, which is being referred to as PEPs, being established. This chart is from the one that is in Montgomery County, Maryland. And this is, again, where they're having to set what their current baseline is for their efficiency, building efficiency. And then what they're going to do is they have to set guidelines, and they have to get to these guidelines in a certain amount of time. And this is going to be based off the building type. So again, these are things that you have to start thinking about, just not today, but in the future. How do I get to my final standard compliance, right? So as we're starting to lay out these new systems, this may be another thing that, okay, well, I have to get a certain efficiency by 2030. So I've got to look at a high efficiency product. We're seeing more and more of these across the country. They're all kind of, again, established a little bit different, but you just need to be aware that this kind of standards are being put out there, and they are regional, county. It really varies. So again, you need to keep up the speed of what's going on, where you're designing the system and going to place it into operation at. This is one, again, that Maryland's probably the one in Montgomery County is probably one of the more aggressive ones that I've seen, but there are plenty out there you need to be aware of. So if we go into efficiency, the efficiency standard that we are testing our commercial boilers to is the AHRI standard 1500. And what we are required to do as a manufacturer is that we have to have a steady state operation to validate the efficiency. and we operate at an 80-degree inlet temperature, plus or minus 5 degrees. The outlet temperature has to be 180. We get kind of a plus or minus the 2 degrees there on that range. And then that is at full fire. So this is, if it's a 2 million BTU unit, we've got to have it at full fire at 80 on the inlet and 180 on the outlet. And then we have a maximum in the space of an 80% humidity range. This standard is probably not, really the greatest thing out there, because none of us are operating a system at, I won't say none of us, but a majority of our systems are not at 80 in, 180 out. But at least this allows you as a design engineer or a facilities manager to be able to compare efficiencies, right? So now if you've got manufacturer A, B, and C, we're all certifying to the same standard. So you can again, it gives you a chance to compare apples to apples. With that said, there is some investigating going on tweaking the standard to kind of pull in modulation. We have a lot of units that have, 20-to-1 turn down, 10-to-1 turn down. So how can we show that turn down value in the efficiency standard? So those are some things that are being evaluated. Nothing has, came to approval yet to move forward on. So we'll take that efficiency. So then as we start to see, and I know everybody has seen some kind of efficiency chart from the manufacturers that they're currently using, or other presentations. One thing over the years that I've had requests was, well, send me that AHRI efficiency chart. Well, that's not really an AHRI chart, right? You got to remember, what are we required to do? We are required to certify 1 point, that we're that 80 in, that 180 out. So all these charts that you're seeing, right, we are testing multiple points, but there's no manufacturer that is testing every point. A lot of this is calculated. So just want to be transparent on that you look at these efficiency charts, majority of that is just calculated efficiency ranges. We are all finding a few points, like I said, but there's no way that any of us have time to run every test at every temperature. The big thing you need to take away from this chart is the inlet water temperature. When we get to 140, we get to 150, we get to 160 on that inlet water temperature, it doesn't matter whose product you're using, everybody's going to be about that same efficiency, and we're really not maximizing what we're calling is that high efficiency boiler. So there's been multiple times through while I've been doing this for 13 years that we get a call from somebody that says, I'm not seeing the return on investment, right? I'm not seeing the gas savings. And the first question you ask them is, well, what's your inlet water temperature? And they're like, well, 150, 160. And, they're just not in that condensing range. So they're operating in those temperatures that they would have, in the efficiency that they would have if they would have kept a standard cast iron or a copper product in there. So just be aware, we need to try to drive to the lowest entering water temperature possible to maximize, going to a condensing product. So if we talk about efficiency and how we verify that, just like we were using the South Coast organization to verify our NOx ratings and to get that certified, we will use AHRI to certify our efficiency. So this allows you as a design engineer, as a facilities manager, to go in, get documentation from a third party on the efficiency. So you'll go to ahridirectory.org. Once you go there, you're going to go up to the product type, and you're going to be able to go in there and you're going to be able to select a commercial boiler, a residential boiler, water heater, chillers, cooling towers. There's all kinds of products in there, commercially and residential, that you can go select. Once you select that product type, then what you're going to do is you'll go to the brand name, you'll select the manufacturer that you're looking at, and then what that's going to do is going to populate all the products that they have in the directory. You will also see under the thermal solutions that's circled on the screen, there's a material. I tweaked the filter a little bit. I selected the stainless steel products. So you'll be able to go in there, select the stainless steel products. Or, if you were looking at a different type of material, you could do that. But then what it's going to do, you go in, you can actually select the product you want to look at, and you hit this certified, the blue reference number. And what that does, it gives you a PDF of the tested and certified document. So this is what your PDF will look like. We went ahead and we pulled one up for the AMP 500. And this is kind of the information you'll see. You're going to see that the reference number for the certification file, you'll see the date. That date's not the certification date. That's the date that you saved the document or you requested the download. You'll get the product name, the model number, the material, and then you'll see the input ratings there and what that combustion and thermal efficiency is. So you may need this for any kind of incentives or any kind of rebates for your files, but that's how you would get there to verify that third-party efficiency. I will say that majority of the high-efficiency condensing manufacturers are participating, but if not, I would question if you're looking at a product and it's not in the AHRI certified program, I would ask ever who you're dealing with, that salesperson, that manufacturer, well, why aren't you participating in that program? It's not that difficult. All we have to do is submit the data, and we have to have a witness test, right? So it's just making sure we're doing the right thing, which is beneficial to you. So also some of the benefits the program offers a manufacturer is if manufacturer A sees something from manufacturer B that they don't agree with, they could actually challenge that manufacturer, and they say, well, I don't believe you're at 100% efficient. Right. And then what they'll have to do is they'll have to take that, file a complaint, and then it's actually they can challenge that and they can test it out. So it gives us, if we see something that we don't like, that we feel somebody's not representing or doing just to the industry, we can kind of challenge each other on that. So that's good. And then also there's some statistical information that we work at that helps us understand what that market truly is in the high efficiency. So there is some other benefits to us from the manufacturing side versus the end user or the facilities manager on AHRI. I want to get into footprint. Actually, before we go to footprint, I want to talk a little bit more about efficiency. I'm going to go back here. So if we look at the efficiency, right, we're gaining 10, 15 points on efficiency. I think what I didn't realize when I first started getting into this was, well, when you're at 80% efficient, right, where is a lot of that heat going? Well, a lot of it's coming into the mechanical room, right? You're losing that from standby loss, from the unit. So one of the first mechanical room changeouts I went into, that was the first thing I heard, 15 years ago was, man, this mechanical room is a lot cooler. Well, because they went from something that just was emitting heat all into the mechanical room to a high efficiency unit that was really not putting any heat in the mechanical room. So that was the biggest complaint about that job, was now they actually had to heat the office space. So the facilities manager office was right next to the mechanical room. So where they weren't spending any money heating his facilities office before, now they had to. So that's kind of just, I look back at that, and that was the biggest complaint about that job, was now they were spending a little bit more money just heating that room, but actually they were saving, but that was the complaint they had. So I just thought I would share that story, something to keep in mind, that the mechanical room is going to lose temperature because of the increased efficiency than what historically has been in there. So if we look at footprint, these are two pictures. So the upper left picture is a competitive product. It's also high efficiency. The bottom is one of our older high efficiency products. And what I wanted to point out was not even high efficiency products are the same footprint. Before we get into looking at the dimensions of a cast product versus a high efficiency, you'll see at that bottom picture, the unpainted housekeeping pad, there's actually room, so this new product that was installed, the our AMP product, it actually saved a little bit of space. So just something to be aware of, that as you're looking, and if space is very critical, every high efficiency product is going to have a different footprint, and depending on that design, it can vary. But this picture really, I just want to show that, this is, two 800,000 BTU units in that picture. So you think about what historically 1.5 million BTUs have looked like in a mechanical room. This just offers an opportunity for a lot cleaner looking, freed up space in the mechanical room. So again, it's anybody that's been in an older mechanical room, it's just a major difference than what we're used to as we transition towards high efficiency. So let's get into kind of the cast iron versus the condensing dimensions. So this is going to be, all these next few slides are going to be from an above aerial view looking down. This is the footprint that we're taking up, square footage of real estate on the ground. So this is going to be at right around a 4 million BTU product. So on the left is going to be the cast iron. On the right is going to be the condensing. So you can see if we had an existing 4 million BTU cast iron, we're roughly taking up about 6,300 square inches. And then when we transition to condensing, we're going to be taking up about 4,800 square inches. So again, as we start to transition, we're saving up space in that mechanical room. We're going to take a look at a 2 million BTU input unit here. Again, cast iron, we're going to be a little under 3,400 square inches, and we'll be a little bit over 2,500 square inches with the condensing. And then we'll get down to 500, a little smaller, probably light commercial opportunity here at a 500,000 BTU, but you can see we're almost actually half the size as we transition to condensing. So now we're really starting to share, free up some space. The one thing that I think is really great is when you start to look at, okay, well, let's say if I've got a large mechanical room and I've got a 4 million BTU cast iron in there, and I want to evaluate maybe some redundancy. So I can say, okay, well, I'm going to take and look at two 2 million BTU condensing units, and I'm actually going to be able to put in my service clearance, and I'm still going to take up less square inches altogether than I did on that 4 million. So now we've got the benefits of redundancy. If one of these units go down, we still don't lose full capacity. Also, this could be something we look at as if we're, maybe budgets are really tight and we can only replace one unit. So now we can actually pull one unit out, put another one in, and then we know we're going to have room to go back for the other one. So maybe that gets budgeted, we put that in, and we still don't take the other one out. So it just gives a lot of flexibility as we move forward, replacing older products with the new high efficiency, just being able to navigate that mechanical room. So just something to look at. Everybody's dimensions are online. Everybody's going to have Revit drawings available, so you can take those Revit drawings or CAD drawings and you can kind of move that around and see what that footprint looks like. And you'll be surprised as you start to move around things in the mechanical room, actually how much space you free up. And then you can actually, even depending on what kind of location you're working with, you can actually maybe turn some of that mechanical room space into usable space. All right, we'll get into water temperatures now. So this is a topic that I think has, been talked about ever since we started moving towards condensing products, right? Is the ASME stainless steel heat exchanger. You're going to see on that heat exchanger, it's going to have a maximum operating temperature, 210 degrees. You will never see 210 degrees out of anybody's product, but that is what the ASME requirement is. And why I say you'll never see 210 degrees is we all have safety temperatures built into our logic. So you may only see a set point of 185, 190, 195. And then what will happen is as that unit gets close to that set point, it's going to start to protect itself. It's going to have a high limit. So the stacked up safety temperatures get to that 210, but you'll never be able to deliver a 210 space heating temperature to a space. So that's just something to be aware is you need to know what boiler you're looking at. You need to figure out what that set point temperature is and make sure that works for your application. If you're in a situation where you're not willing to sacrifice a 200 degree set point, a condensing product may not be the product for you because you're just not going to be able to get there. So that's something you need to look at. And again, this temperature is going to vary per manufacturer. We're not all the same, and it's based off of our control logic that whatever those stack up temperatures are to get to that 210, so we can safely operate within the ASME standard. So again, if you're really set on having high water temperatures, a condensing product may not be the best for you, because then you're probably not going to hit those temperatures, but then also your return water temperatures are going to have you in a range where you're not going to be condensing. If we remember that condensing chart, or the efficiency chart, where we were saying, okay, if we're at 150 on the return water temperature, we're not going to be higher than 90%. So that kind of drives towards this next slide on the return water temperature. If you're looking at different material, you're going to see these three temperatures. You're going to see people reference 140, 135, 130 for return water temperatures. There's a lot that goes into this, but you want to be in that range somewhere, right? So it's safe to say if you're at 160 on your return water temperature, you're not maximizing your high efficiency unit. So how do we get to lower return water temperatures, right? We need to look at outdoor reset. How do we adjust that to try to drive towards lower temperatures? And then also, do we evaluate new heat emitters, whether that's fan coils, whether that's radiators, whatever we're doing, right, to take that heat from the hydronic system, put it into the space, right? We can maximize the efficiency of the boiler by adjusting those heat emitters. That's not always feasible because of budgets. So if not, then we need to look at outdoor reset temperature. How can we drive those return water temperatures lower? I don't think any of us likes that call. That's, again, back to saying, well, I'm not really seeing my savings. Well, it's due to that return water temperature, or I was unwilling to sacrifice, right? I had a high delivery temperature I needed to meet, which then forced me to get higher return temperatures. So again, we just need to always target the lowest possible return temperatures to make sure that we're getting the best return on investment with high efficiency equipment. So that's all I've got for the presentation. I couldn't get through the whole presentation without doing a plug for some of our condensing products here to kind of close this up. So the products we offer under the Thermal Solutions brand, we have the Apex, which is 5 models. We're going to go from $399 to $800,000. We have our AMP product, which is 13 models, takes you from 399,000 BTUs up to 4 million. And then we have our Arctic unit, which is 11 models. It takes you from that 999 to 6 million. So I'm not going to get into product specifics about these. They all have their unique feature sets. We could sit here and say, well, this product's better from this one because of this, but really just want to let you know, as you look to transition from your existing systems to a high efficiency, that we have a full line of products here that we can support you with. And if you want to know more, we can get you in contact with your local manufacturer's rep, and they'd be glad to kind of work through the best product for your application. So with that, just going to say, right, as we're sitting here talking about going from cast to condensing, that may not always be the best option. The best option for you, because of some of the things we talked about, return water temperatures, or maybe I need a higher delivery temperature, it may just be fine, and the best thing for your customer to go from a cast back to going to cast iron, right? But if not, we would love to help you in that transition, going from a cast to a high efficiency condensing product. But again, that may not be the best decision. We'd rather help you make the right decision for your customer, and that could be going back with the cast iron unit. So in summary, right, we talked about the different drivers. We talked about the emission standard. I think this is going to be the one that's going to continue to grow as we get pushed to lower emissions across the country. What does that look like? How do we do that? I'm a big proponent of saying let's go high efficiency. That's the safest bet, right? A lot of the country wants to move just straight to electrification, decarbonization, but going high efficiency does lower your emissions. Again, efficiency standard, We are testing at 80 in, 180 out, not real world, but it gives you an opportunity to compare apples to apples. And then, we can get creative with what that new mechanical room looks like, decreasing the footprint of that high efficiency unit. And then again, let's just look at water temperatures very closely to make sure we are putting the right equipment into the right system design. And then Charlie, I'm going to kick it over to you here, but we're going to do another webinar on August the 6th, and we're really going to go more technical. This was just a high level overview. So we're going to really get into the, venting. As we move towards condensing products, there's moisture in the flue product. So how do we, navigate that? We don't want those flue products going right onto our building. Condensate management, we need to make sure that we treat that condensate. Also, if it's an outdoor boiler, we got to make sure we protect the condensate from freezing. And then anybody that's been doing this for long enough, gas pipe sizing, just because you've got a 1-inch gas pipe coming out of the unit doesn't mean you can run a 1-inch gas line 300 feet to the meter, right? So we'll talk about that. But again, I appreciate everybody taking the time to have this discussion today.
Yeah, thank you, Dan. That was great. That was great. Appreciate the time here today. And of course, if you're still with us here now, we're going to keep the chat open for a little while longer. Make sure we can answer any questions you have right now off the top of your head. But before you leave, just make sure you know that we're looking to invite you to the next phase of this. So if you've attended this one or registered for it, we'll be sure to send you an email here shortly, just inviting you to register for the next installment of this series here. But definitely appreciate everybody's time here joining us today, and thank you, Dan. I did have one question for you, though. I guess in terms of, you talked about some bellwethers in terms of those regulations or emission standards. I mean, if you were an engineer, out there today, you're probably operating in multiple places, right? You have to think about multiple jurisdictions for these things. So what would you recommend to them in terms of how do they, stay in front of these things and at least are aware of the ones that are directly impacting them?
Yeah, Charlie, that's a great question. I think that's, really we're all kind of struggling to keep on top of this because it's moving so quickly. But again, I would first thing I would do is, rely on the manufacturer rep in your area to see, what information they have. And then there's also, different sites you can go to, like the state sites will kind of talk about some of this, but really, the manufacturer rep in your area is that expert, whether it's for our product or another product, right? They're on the grounds, they're dealing with the local organizations, so they can help you out, and then they can always reach back to the manufacturers too to kind of see what they're hearing. But it's ever changing, so unfortunately, this is not a great answer. But it's like you could start your design now, and the way that the environment is, by the time your design finishes in 12 months, there's probably going to be something new set there that you're going to have to look at because it's moving quicker in different parts of the country.
Yeah. And if all else fails, you just call Dan, right? Be all right. That good deal. All right. Well, no questions have come in here. So again, thanks everybody. We'll wrap it up here and make sure we share a recording of this event, and looking forward to seeing everybody here next time. Thank you.